Nomenclature. Nomenclature of organic compounds. So the carbon forms a billions of compounds. So those compounds are easily remembered through a nomenclature. So your systematic nomenclature, a systematic procedure for give the name for organic compounds, generally it involves 3 steps. Okay. So this nomenclature is according to IUPAC. So discuss according to IUPAC nomenclature. IUPAC means International Union Pure and Applied Chemistry. According to IUPAC, the nomenclature of organic compounds are involved in 3 steps. So based on 3 steps, we give the name for organic compounds. So those 3 steps, in that first one is prefix, and second one is root word or word root, and next one is suffix. This, in that first one is prefix. So prefix means it explains nature of carbon or nature of substituent. Okay, prefix is explain nature of carbon and nature of substituent. So that is your prefix. Only prefix explains what is the carbon nature, that is your cyclic nature or straight chain or closed chain. What is the substrate? Your substrate is chlorine or bromine or iodine. Which type of substrate is present? So that is explained by a prefix. So generally these prefixes are classified into 2 types. The prefixes are classified into 2 types. One is A. In that A, first one is primary prefix, and next one is B, secondary prefix. Okay, prefixes are 2 types. One is primary prefix and one is secondary prefix. So in that A, primary prefix. So this primary prefix is applicable for only cyclic compounds. It is only applicable for cyclic compounds. For example, if cyclic compounds are absent, so there is no use of primary prefix. For example, so if you consider a 3-member ring, this is your 3-member ring, here 3 carbons are present. In primary prefix, if it is a cyclic compound is present, here prefix means first one is cyclo. You can write a cyclo. Okay. Here 3 carbons are present. Here prefix is, here ring is cyclo. Here 3 carbon means prop. All are saturated means propane. Its name is cyclopropane. Means in primary prefix, if it is cyclic compounds are present, here prefix is cyclo. For example, if you consider this one, so 5-member ring, here also cyclic ring is present. What is the name? You can write again, prefix is cyclo. Here 5 carbon means your root word is pent. This is also again saturation, that is pentane, cyclopentane. Or if you consider another example, this one, your 6-member ring, here also prefix is cyclo. If it is cyclic compound is present, the prefix is cyclo. Here 6 carbons means X, and this is your saturated, that is your hexane. So these are the examples of primary prefix: cyclopropane, cyclopentane, cyclohexane. If it is cyclic ring is absent, there is no use of primary prefix. Okay. And next one is secondary prefix. B, secondary prefix. So this secondary prefix is explained second factor, that is nature of substituent. So nature of substituent. So what type of substituent is present? Nature of substituent. So nature of substituent is explained by secondary prefix. Examples. If you consider a group and its secondary prefix. So these secondary prefixes are very important. Functional group, or in that group, for example, here OH group is present. So that OH group is nothing but alcohols. If alcohols are present, that secondary prefix is hydroxy. So remember. Or if it is ethers, so ethers are present. So its formula is like this. Okay. If ethers are present, that name is, the secondary prefix is alkoxy. Means, for example, if it is oxygen interact with methyl group, that is methoxy, propoxy, butoxy, like that. Or if it is aldehyde group, so aldehyde formula is CHO. If it is aldehyde group is present, its secondary prefix is formyl. Okay, this is your aldehyde. Or if it is keto group is present, ketone. Whenever the ketone group is present, its secondary prefix is oxo. Okay, oxo. Or if it is COH group, so carboxylic acid. So if it is carboxylic acid is present, so this secondary prefix is carbonyl. Carboxy, its secondary prefix is carboxy. Or if it is C double bond O X, so this is called as acid halide. So whenever the acid halides group is present, its secondary prefix is halocarbonyl. Its secondary prefix is halocarbonyl. Or if it is halogens, so whenever the halogens are present, generally halogens are chlorine, bromine, iodine, fluorine. Whenever the halogens are present, its secondary prefix is halide. Halide. Okay. So these are your secondary prefixes. Means secondary prefix is explain nature of substituent, which substituent is present on the carbon. If the substituent is OH group, the name is hydroxy. So generally this OH group is called as alcohols. If it is ethers are present, alkoxy. Aldehyde group is present, its secondary prefix is formyl group. Sometimes this is called as oxo group. If this ketone group is present, oxo. 1-oxopropane, propanone, or 1-oxopropanaldehyde, like that. COH group is present, carboxy. Acid halide, halocarbonyl. Halogens, halide. So this is a prefix. So means the prefix is explain nature of carbon and nature of substituent. These are classified into two types, primary prefix and secondary prefix. Primary prefix is explain only cyclic compounds. It is applicable for only cyclic compounds. If cyclic compound is absent, in that case there is no use of primary prefix. In that primary prefix, their prefix is cyclo. The cyclo is written before the name, before the root word. Okay, this is our first step, that is your prefix.